In this video, we are going to learn about assignment algorithm of solving a given operations research problem. Assignment algorithm is a special kind of a transportation problem where we do use this algorithm to assign things to activities. Variations are some special cases in assignment problem. We know that an assignment problem or given payoff table is a square matrix where we have n into n number of rows and columns. These are the four special conditions where we can apply Hungarian rule also by making certain changes earlier. The first variation in assignment problem is that unbalanced assignment problem. If the given payoff table is not a square matrix, in some cases, you have to add some dummy rows or columns in order to make it as a square matrix. That is an unbalanced. Likely the unbalanced transportation problem, we also balance the unbalanced table by adding some dummy rows or columns. If you have 3 rows and 2 columns only, then you have to add one more column to convert into 3 by 3 matrix. That is. And ultimately, we need to get a square matrix. That is an unbalanced transport assignment problem. Second one, multiple optimal solutions. Though the way is different, but ultimately you reach the same goal. That is multiple optimal solutions. For the given assignment problem, we have more than one solution existency. That is multiple optimal solutions. Unlikely, for example, if I solve the assignment problem by using Hungarian rule, I got one solutions. Some others solve the same assignment problem and they also got the solutions. But the different pattern, the different assignment is multiple optimal solutions. And restrictions on assignments. In some cases, a resource may not be allocated to particular activity. For example, mission 2 is not to assign to work 1. There is a restriction given on some conditions, on some activities it is. And performing that work on that machine may costlier. So, in such cases, we restrict the assignments. So, that is restrictions on assignments, where we have these restrictions on employees, machines, resources, activities. That in that conditions also we solve it by using Hungarian rule. We see an example in further. The last one, maximization case. Up to now we see some examples which are a cost minimization rule, where in some cases also we have to work on the cost maximization rules, where we have to convert the given table into cost minimization techniques. We know that if a profit or revenue is given, we have to maximize the result. If a cost or expenses are given, we have to minimize it. Up to now we see the problems which are minimizing cost or expenses. If in some cases a matrix is given related to profit or revenues, in that case you have to maximize the given solutions. We obtain this maximization table by following 2 ways. Number 1 is place a negative sign on each and every element of the given payoff table by converting it to the cost values. Second one, largest element. Identify the largest element among the given elements and start subtracting that value from each and every value, including itself. By that, you can able to convert this cost matrix into a profit matrix. Initially, we are given with a cost matrix, a payoff matrix. By subtracting row minimum, column minimum, we convert into cost matrix. We can't maximize the cost. We have to minimize the cost. So, maximization case, we have to convert that table into profit payoff matrix. How do we convert that? By any one of these two. Place a negative sign on each and every element and start from there onwards the repetitive process called Hungarian. Identifying column minimum, row minimum, subtracting and assigning one assignment to one particular employee. Or identify the largest element among all and start subtracting it. Thank you for watching. Please subscribe to my channel.